We're continuing to look at differentiation. And what you're seeing here is the graph of y equals x squared. Now, remember now, when we talk about differentiation, it's a matter of finding the derived function. So what you find is the derivative of a function f of x. In this case, what we have is f of x equals x squared. In other words, y equals x squared. Now, I want to make the curve a bit thicker than this. Okay, good. So, what we have here is the curve of y equals x squared. Now, let us find any point on the curve for our x and y. What we want to do is differentiate y equals x squared from what is called first principles. Alright, let us say our x is here. And if our x is here and we project to the graph, to the curve and go to the left, this is our y. But what is y? This is x squared. So let us say this is x squared. Now, we take another point. Say it is here that we find the other point. This is the first point, this is the second point. So this would be x plus something. If we call this distance h, then here, this point would be x plus h. Because from the origin to here is x, and then we go h more, so it is x plus h. For example, if x was 1, and this is another one, we'll be at 2. If x was 1, and we add 0.5, then we'd end up at 1 plus 0.5. In this case, we would have x equal 1 plus h equals 0.5, and we'd end up at 1.5, which is here, right? Now, this is x plus h. If we look at the graph, I'm trying to draw a straight line here. Seems to be going off course at times, but if we go up to the curve and then to the left of the curve, we have the y value that corresponds with x plus h, and this would be x plus h squared. So that's x plus h squared. Now, let us call this point point 2 and this point point 1. What we find is that x1 is x plus h. So let's write x1 as x plus h. No, x1 is x. x1 would be x. Just x. Alright? So this is point 1. So x1 is x. Then we have y1 is x squared. So in this case, we have y1 equals x squared. Then x2 is x plus h. So we have x2 equals x plus h. And what is y2? y2 would be x plus h all squared. You see that? So y2 is x plus h all squared. Now, if we should draw a line through P1 and P2, these 2 points, what would be the gradient of that line? It would be y2 minus y1 over x2 minus x1. That's the gradient of that line. So let's do that. The gradient y2, so call it g equals y2, which will be x plus h squared, minus y1, which is x squared, divided by x2, which is x plus h, minus x1, which is x. Alright, so you see that. That would be the gradient of that line. So what we have, let us say this is our line, and this line passes through both points, both P1 and P2. Alright, so this is the line. Let me make the line a bit thicker than that and change the color to some type of greenish also. Alright, so this is our line that passes through P1 and P2. So the gradient is y2 minus y1 over x2 minus x1. Now, the thing is, if we put our P2, make our P2 here closer to P1 as we did previously, then what we would have is our line, the gradient, would be a little less. And then we could say that being that P2 is closer to P1, the h that we had before gets smaller. So x plus h would end up here. And the closer we put P2 to P1, the smaller h would be. And the limit is when it approaches 0, so it becomes x. Now, here, the gradient would get closer to the real gradient, to the true gradient, as h approaches 0. Right? So the true gradient of the line would be the limit as h approaches 0 of x plus h squared minus x squared over x plus h minus x. Now let's simplify this. Let me partition the board and do the simplification over here. So x plus h squared is x plus h times x plus h minus x squared all over x plus h minus x. But x plus h minus x is the same as x minus x plus h. So x would subtract itself, x minus x. So all you have under here is h in the denominator. Now, if we multiply out the brackets here, we would have x squared plus hx plus hx plus h squared. But hx plus hx is 2hx. So let's just put it as that. It is plus 2hx plus h squared minus x squared all over h. But guess what? X squared, subtract x squared up here. So it simplifies to 2hx plus h squared divided by h. Now, this gradient, if we factorize the numerator, we put h outside the bracket and 2x plus h would be inside the bracket over h. But now h cancels h. So what we have is 2x plus h. Now what is the limit of this as x? As h, not x. What is the limit of this as h approaches 0. The limit of all this will be 2x plus 0, which is just 2x. Now, what it's showing is that the derivative of this is 2x. What that is saying is, whatever point you choose, the gradient of that point is always 2x, whatever point you choose for x. And what that is saying is that the derivative of x squared is 2x. What we really did a while ago was differentiate x squared from first principle. So you can say that when you differentiate x squared, you write it as dy by dx equals 2x. That is, if y equals x squared, then dy by dx is equal to 2x. Right? You can also say, in another way, that if you write it as f of x is equal to x squared, then f prime x is equal to 2x. So that's a matter of differentiating x squared from first principles. Let's switch back over to the graph. So this is the graph we have. Now we'll examine this a bit more, but in a different video. So I will see you then.